Welcome to homework.
Solving the part A, we have the dissociation of SrOH2. We know that 1 mole of reactant provides us 2 moles of OH negative ion species. So the concentration of OH negative ion will be double the concentration of reactant, which gives us OH negative ion concentration as 3.0 multiply 10 raised to power negative 3, from which we can determine the pH value, which comes out as 11.48. For part B, we write the dissociation of lithium. We have to calculate the moles of lithium hydroxide, which is mole is equal to mass divided by the molar mass. Substituting the values, the number of mole turn out to be 0.0938, from which we can determine the molarity of the solution. Formula for molarity is number of moles divided by the total volume of solution in liters. The molarity is 0.3756, which is equivalent to the concentration of OH negative ion. From this, we determine the pH of the solution as we determined earlier. So we are provided with pOH concentration. So negative log of OH ion concentration, which is equal to the molarity. Substituting negative log of 0.3756, pOH value turn out to be 0.4253. From this we calculate the pH value, which will be 14 minus the value of pOH. So 14 minus 0.4253 gives me pH value as 13.5747. To solve option C, we have to calculate the molarity of dilute solution using the relation M1V1 is equal to M2V2. Substituting values into the equation, we find out the diluted molarity M2, which is equivalent to the concentration of OH negative ion. Using the same steps as we did over here, we find out the pH value of the solution, which is equal to 9.994. Following the exact same steps as option C, we substitute the values to determine the M2 molarity of diluted solution. So M2 will be equal to 0.105 multiplied with 5 ml divided by 20 ml. M2 will be equal to 0.02625, which is also equal to the concentration of OH negative ion. So calculating the final molarity, T of calcium hydroxide CaOH2, again using the same formula M1V1 equals M2V2. M2 value will be equal to 9.5 multiplied with 10 raised to power negative 2 multiplied with 15 divided by 20 ml gives me a second value 0.7125. This is equivalent. So now we have to determine the concentration of OH negative ion. OH negative ion will be double the concentration of 0.07125, gives me 0.994. 1425 m. We have OH negative ion concentration. So the total concentration of OH negative ion will be sum of this along with sum of this, which gives me total OH negative ion concentration as 0.17 m. From this, we need to determine the total pH value of the solution. So we have POH is equal to negative log of OH ion concentration. OH ion concentration is 0.17. Substituting that, 0.17 gives me POH as 0.772. From this, we have pH is equal to 14 minus the value of POH. So 14 minus 0.772 is equal to 13.227, the pH.